Alrighty, we're going to get started with a new chapter today. We're going to talk more and more about circles. You should have gotten the announcement on Monday that outlined for you how long we're going to be doing basically everything until the end of the year. Circles will end on the 27th, so we have, let me count here. We have 1, 2, 3, 4, 5, 6 days of circles, and then basically review until the end of the year. So I'm going to start here with some definitions, and we'll look at some examples, and we'll be finished. So the first thing I want to talk to you about is what's called a tangent line. And tangent lines have huge implications when you get to calculus. In calculus, it'll start to talk about tangent lines, not in terms of circles, but like if you were doing some kind of a curve that represented velocity, and you wanted to know how fast something was going at any one point. A tangent line is something that just skips, just barely touches at any particular value. And depending upon where you are, that tangent line, which represents the curve at that one point, changes. So like if I'm tangent just skipping on the circle on this side, the line looks like this. But if I want to be tangent here, I can't make a line that looks the same. I have to just skip it. And you'll see the trajectory of our lines are going to always change based on the location. The main idea for today is if two segments from the same endpoint are tangent to the circle, then they are congruent. So in our picture here it says here and here are where the tangents are occurring. These are our tangent lines at a common point S, okay, sharing the same endpoint. This is our endpoint. Then we would say that RS and ST are the same. So if RS and TS are tangent to circle P, then RS is congruent to TS. Let's look at an example. It says lines AB and AD are tangent to circle C, find X. Using what we know, if this is the tangent points and these are the tangent lines, if they have the same endpoint A, then they are congruent, which essentially means you can set those two lengths equal to each other. And solving is always a secondary concern in geometry class. If you understand that, then you're good. Now, you might need some help on how to solve this. Remember, solving, you're always doing the opposite of what the problem says. So if you see plus, you subtract. And then the last part is if you see a square, you need to square root. Okay, and whenever you're square rooting and you're solving, you do need to remember, this is a small reminder from quadratics in Algebra 1, you need to put plus or minus. There's actually two answers here. X equals 5, X equals -5. Here's why that's two answers. If you plug that number back in, 5 squared is 25, 25 plus 24 is true, 49. You can do the same thing with -5 though. -5 squared is still 25. So there are two answers in this problem. The next part about tangents says that if a line is tangent to a circle, then it is perpendicular to the radius of the tangency. So if you see this radius is touching at the tangent spot. Now there are radii all over this from middle to edge, so it has to be the one that is touching right at that tangent spot P. And so we can go ahead and say that's a 90-degree angle. If, let's say, line L is tangent to circle Q, then QP is perpendicular to L. A lot of times the type of problem you see using that theorem is a Pythagorean theorem problem. So like if you see here's our radius R, and then we have a tangent right there at A, that makes a 90-degree angle. and you can do the a squared plus b squared equals c squared formula to find any missing value. So like if this whole thing was 10 and this whole thing was 4 and this whole thing was missing, real easy problem. I have no qualms about you trying to figure that out. This is very similar but a little more complicated. Okay, and what it's trying to get you at, like let's say you're taking I-STEP, is they want to understand, do you know if this is 4, what's this part? And the trick here should be that if you remember, we said there's these radii all over the circle. Well, that's one right there. That's R. Okay, take that and use what you know about the Pythagorean theorem. A and B should be your legs. So we'll say 9 squared plus R squared. And then using what we learned back in semester 1, we have the segment addition postulate of R plus 4. So we get 81 plus R squared equals, okay, I know what you're thinking, it's not R squared plus 16. When that says square, that means to take whatever is being squared, so R plus 4, and multiply it times itself. So we need to actually distribute, or some people call this FOIL, R times R times 4. 4 times R, 4 times 4. And combining your like terms gets us to here. So you got digits with no variable, digits with 2 variables, that's R squared, and then you have these two here that each have just 1 R. Okay, now combining like terms on each side is finished. You're done simplifying. Now you need to start solving. And that's going to require you to put like terms together on opposite sides. So for instance, there are 2 R squared, so we need to put those together. However, they just happen to cancel. All right, 16 and 81 go together. Let's see here, it's been a while. 81 minus 16 is going to be 65. And then dividing by 8. We get R equals, I would just use a mixed number, so 8 goes into 64 8 times with a remainder of 1. Not to backtrack too much, but this type of problem here where it says to find the perimeter, it kind of goes along with the fact that if you have an endpoint in common on a tangent, so tangent, tangent, same endpoint, that means that these are the same, so those are both 5. And then here, endpoint, so if that's 4, then that's 4. And if this is 3, then this is 3. And remember, perimeter is just finding the entire size of each side and adding them together. So together this whole thing's 9, 5 and 4, 5 and 3 make 8, 4 and 3 make 7. So the perimeter is side 1 plus side 2 plus side 3, 8 plus 9 plus 7. Well, 8 plus 9 is 17, plus 7 is 24. And our last theorem for today is the converse of the first part. So remember, the first part said that if a line is tangent to a circle, then it is perpendicular, and then converse, that is the changing of the order. So now it's saying if a line is perpendicular, then it is tangent to the circle. So in this here, it says if it is 90 degrees, if QP is perpendicular to L, then L is tangent to circle Q. Our last example here, finding X, a missing value here. If you look, there's a tangent here, and that is a radius. So in this whole four-sided figure here, what I would point out to you is that you should know 2 of the angles they didn't give you, because they're 90. So if you take, okay, this is a kite-looking shape, has, let's see, 4 sides, so that means it's 180 times 4 minus 2, 360 degrees. You could say 360 equals X plus 90 plus 90 plus 130, and then you can just figure out what this missing one is by combining your like terms and solving. Let's see, that would be actually 310. And subtracting 310, we get 50 degrees. Those are all the problems we're going to look at from this section. Make sure you finish the Pearson assignment, and from now on we'll try to have those in by midnight. You can turn anything in whenever you want. The midnight deadline is just to help me do the attendance from each day. If there's any other assignments you want to do, go ahead, fill them in, turn them in, and I will add those points. You can definitely raise your grade by the end of the year. Anything's game. Anything during quarantine is 100%. Anything before that will be 50%, as it would have been anyway. If you have any questions, let me know.